hope my slides are visible. Share my screen. Okay. Welcome, guys. Good evening, everyone. I am Karthik Jadhav, research scholar in the Department of WRDM IT Roorkee. So I welcome you in today's summary session of course Soil Science and Technology. So you guys know that this course is basically conducted by Professor Chakravarti from AGFE Department, IIT Kharagpur, and I am teaching assistant from the NPTEL side as part of my PMR teaching assistant duty. So before we begin, let me uh, quickly remind you that your exam is also coming. So if you have any query till now, whatever we have covered, you can directly reach me out to this provided email ID. I also request you to access all the lecture materials that I already uploaded in this YouTube channel. Now, all the materials that I used for during since last 12 weeks, I'm uploading here. I will also upload today's lecture in this drive folder. You can also provide your valuable feedback in this feedback Google feedback form. It's created by NPTEL team. So okay, so let's start today's session. So as you know that this today's session basically will focus on the course overview of this course, what we have covered till now, and what are the key learnings that we have learned today about these topics, and how this integratively help us to uh, design soil, either soil science, soil remediation techniques, or improvement of soil water or irrigation planning, soil water movement, and also mapping all the soil water properties, right? And how that we can betterly use in the phase of climate change. So let's begin with, so in week number one, or basically initially we have focused on the basics of soil, right? So in that we have covered like what is soil. So we know that soil is the fundamental element for the life, and that provides various functions for us, like it providing various crops that is necessary for us, then it providing various environmental benefits like carbon sequestration, and it also help us to recharging our groundwater resources. So the benefits of soil is that cannot define it. It is n numbers, and that we whatever we can think that whatever because of soil only we have or we are on the earth, we can say like that also. So that's why it is very important to learn about soil. So in this first lecture that we have understood all these things, and then we got to, or we have started learning about how soil get formed, right? So formation of soil, and this formation, that's basically we have divided it into the through the weathering of soil. So there are two types of weathering, we can say three types. So first is physical, second is chemical, and biological weathering. And then that weathering ultimately form the soil over the long run. And then this formation is depending on the rock types, and that formatted soil also we can classify it based on its soil physical, chemical, and biological properties. So all this classification come under soil taxonomy. So this lesson ultimately help us to visualize the soil as a living dynamic system and essential to life, that also help us to achieve food security and better environment. moving forward, we explored the soil physical properties, that is soil texture, structure, porosity, and density. And we know that all these soil physical properties influencing soil water movement. Also, soil water or soil air movement. Also, it help us to or help us to get to know about what is the water holding capacity of particular soil, and that water holding capacity ultimately help us to understand the how we can betterly plan our irrigation, because we know that most of the area of the earth is covered by agriculture, and this agriculture is a very fundamental requirement of any lives, right? Because without food we cannot survive. So considering this, agriculture plays a major role in our life, and in agriculture the irrigation all plays again crucial role, right? Because without proper irrigation we cannot get desired yield. And you know that nowadays there is an increasing in population. Also the requirement of water, food, and other natural resources are growing exponentially. So due to this, we need to conserve this resource very precisely, and understanding soil physical properties that we have discussed in week number 2, that is very important. So in addition to this soil water movement, we have also divided this soil water into the water energy potential concept. So we have covered about matric potential, osmotic potential, and gravimetric potential. Then we dwell into the chemistry of soils. Since we have covered physical properties, then we have uh, go detail about the soil chemistry. So in that we have basically found out that soil clay particles. So in soil texture, we have sand, silt, and clay. And the clay particles have a very small, its size is less than 0.002 mm, right? And this smaller size is directly influencing the soil chemical properties. So that smaller size is also known as the soil colloids, and these colloids have a higher cation exchange capacity, and their charge dynamics is uh, generally affects how this it governs the nutrient retention, pesticide sorption. And then we have also covered diffuse double layer theory. Then we grasp the electrostatic interaction that dictate soil behavior in saline and sodic soils. Next to that, we have focused on plant nutrition in the continuation of soil chemistry lecture, because we know that after water and air, plant nutrients are also a fundamental requirement of any crop. So for that, we have covered various macro and micronutrients, and in that we have in detail we have covered about nitrogen cycle, phosphorus cycle, and potassium cycle. So we understand their availability in soil, their movement and methods of measurement like calorimetric and flame photometry. And we also briefly discuss about how we can measure pesticides, right, through advanced technique like GCMS and LCMS. In parallel to that, we have studied organic matter. So it is a biological property, and this is the central to soil fertility. So we investigated decomposition processes both as and aerobic as well as anaerobic, and how compost and microbial communities contribute to the nutrient cycling and carbon sequestration. So considering this, uh, we have also focused on the soil degradation and contamination. So in first part, we can say that we have covered about its physical, chemical, and biological properties, and then we have started about learning of the how our soil or a soil as a natural resource is degrading day by day, and what are the contaminants that impacting our soil. So for that we have covered all the processes like erosions. So in that we have covered water and wind erosion. Also we have considered the contamination. So in the contamination side, we have focused on the organic contaminants and inorganic contaminants. So in organic contaminants, we know that it have a it is impacted by either PFAS, endocrine disrupting compounds, pesticides, and also other emerging contaminants. And while inorganic contaminant sites, we have various heavy metals, namely cadmium, arsenic, nickel, copper, and zinc. Okay, and once these contaminants will introduce to the soil, particular soil, they have properties like bioaccumulated over the time, or also bioaugmentation is happening to other food chain. Okay, so that's why it is very important to remediate it. So for that we have also discussed about various remediation techniques like biostimulation, bioaugmentation, and phytoremediation. And after this lecture, we have also dwell into the integration of this all our knowledge into the modern tools. So once we have a point scale data of all these properties of soil, like physical, chemical, or biological, and also we have a knowledge about what are the fundamental problems. So we cannot use that, or it is very complex to use that uh, data at certain scale, right? Because this point scale data have a various limitation, because it is only for one point data. So suppose you have one district and you are just having data of this point. Okay, that's why this point not representing the entire district. So so due to that, you need to collect some more samples surrounding this cover areas that representing different land use type, different soil type that present in within the district. Then even this point, this 6 point, is not representing entire district. So that's why what we are doing, we are interpolating these properties throughout the district using modern technologies like GIS. Okay, and to monitor this location, exact location, we have GPS technologies. So in GIS, we have learned about basic of mapping and spatial analysis, and then we have also dwelled into the advanced techniques of geostatistics like flagging, variograms, and spatial interpolation, and that help us to assess and predict soil variability. After that, we have also focused on the advanced techniques like diffuse reflectance spectroscopy and PXRFs that introduce us an invasive, uh, a non-invasive, a portable, and a rapid method, and that help us to analyze various soil properties. So this is closely linked to the concept like spectral signature and absorption mechanisms. Later, we tackle the more advanced techniques, the data analysis technique, because this for large scale data, it is not like that we have a few number of sample. We have large number of data set for suppose for entire India, right? And in that also we have a huge heterogeneity. So to cover that heterogeneity, we have approaches, various machine learning approaches, so that learn from that data itself by various mechanism like decision tree, card models. The card is basically classification regression trees model and random forest model. So that allows us to classify and predict soil behavior using large data set. We explore the logistic regression or categorical model and that help us to understand the various accuracy measures like overall accuracy, kappa coefficient, user and producer accuracy. So after that, finally, we have explored transfer function that specifically dealing about to estimate the hard to measure the soil property using easily measured parameters like texture, organic carbon, and bulk density. So we understand different types of transfer function like point-based, parametric based, and semi-physical approaches, and significance of spectro-transfer function in digital soil mapping. We concluded by reflecting model validation and uncertainty, because once we are developing any model, through some data. So that model is only valid for that data range. So data, so that specific region have certain limitation, have a certain types of land use cover, certain types of soil. So if you are using a model that is developed for this region, suppose for some US region, and that model we are using for Indian conditions, so that is not applicable for us. So to use that model in our region, we need to first train this model and then again validate considering other data set. Okay. And also one of the fundamental properties that we need to consider, that is uncertainty analysis. So that will help us to remove biases in the data set and help us to build the accuracy and reliability of our digital soil maps. So with this, we have ended up our lecture 12 lectures or week 12 weeks, and in that we will basically cover about the fundamental of soil, right? How it gets formed, what are its classification. Then we have moved towards its discuss about soil physical property, soil chemical property, and soil biological property. Once we have that fundamental, then we have focused on the problematic soil. So how soil gets affected by various problems. So in that we have covered physical problem and chemical problem. Also, we have focused on the biological problem. So in physical problems, we have talked about various degradation, like degradation by water, wind, that a physical factor, also ice, we can say, in hilly region. While on the chemical side, we have focused on organic and inorganic contaminants and how that this can be removed, right? All this physical and chemical degradation, degraded soil. Then we have move towards GIS and GPS side, so that help us to integrate the large scale data and analyze uh, this large scale data, and that help us to develop various strategies to remediate or implement some policies to government. And then we have also touched up to some innovative techniques, that is diffuse reflectance spectroscopy and PXRF, that is new or modern techniques that we are generally using for estimation of soil properties. And then we have once we have this large scale data which is monitored on the field, and with some uh, heterogeneity, right? So how we can handle that data using various machine learning approaches, okay, like decision tree, cart models, or random forests, and how we can validate our model using various techniques. Then we have also explored the pattern transfer function. So this is the tools that help to estimate hard to measure soil properties using easily measured parameters, right? And there are various types of pattern transfer function we have focused. And then we have concluded our session, last session, with the MCQ that we have covered in all the sessions. And today we'll basically focus on some important concepts and related multiple choice questions. So let's start this session. So before we begin, if you have any query, kindly write in the chat box, or you can also ask now. Hello, hello. Okay. So let's start multiple choice questions. If you do not have any query, so question number one: which of the following particles is biggest? So option A sand, option B silt, option C clay, and D all are of equal size. We know that among sand, silt, and clay, sand particles are the biggest one. So correct answer is option A, and we know that its size is in between 2 to 0.05 mm. While silt have a size of 0.05 to 0.002 mm, right? While clay have size of 0. Less than 0.002 mm. And you know that this particle size distribution is directly impacting the water, nutrient, and air movement. And in case of sand, we know that it have a higher water infiltration capacity as compared to silt and clay. While in case of water holding capacity, we know that clay soil have a higher water holding capacity as compared to remaining two. Correct answer here is sand. Right, sand is greater than silt, and that silt is greater than. Question number two: which rock is formed from volcanic deposits? Igneous, sedimentary, metamorphic, and all of the above. So we know that in rock cycle it is a continuous process that describes how rocks are formed from one type to another over geological time, and it demonstrates the interaction between Earth's internal and surface processes. So yeah, generally we know that whenever magma get formed and that magma get cools down, that generally forms igneous rock. So the correct answer here is after the uh, rock that is forming from volcanic deposits. So from volcanoes and it get deposited and that forms igneous rock. So correct answer is A, right? Also, whenever that igneous rocks gets melting down again, that again forms a magma. But if we go ahead and if there is a sufficient weathering and erosion of this igneous rock that forms small sediments, and that compaction and cementation of that sediment ultimately form the sedimentary rocks. And under the heat and pressure condition, the sedimentary rocks form the metamorphic rocks. So here are the famous one of example of igneous rock is basalt and granite. Then in case of sedimentary rock, it is sandstone and limestone, while metamorphic rock is marble and slate. Question Next question: which component of soil occupies 45% volume? Air, water, mineral matter, or organic matter? We know that air is having around 25%, water is also around 25%, while mineral content have 45% distribution that covers almost 45% in any soil. And remaining 5% is covered by organic matter, and in organic matter distribution we have organisms that cover 10%, roots cover 10%, and 80% is covered by humans. So here correct answer for 45% volume that is covered by organic matter. Correct answer is option C. How many orders are there in USDA soil classification system? So option A 2500, 444, 68, or 12. So we know that soil order is generally we have a total 12 soil order. So order is basically highest level to categorize soil into broader groups based on formation processes and dominant soil processes or dominant soil properties. There are total 12 orders. Then we have suborder. Okay, so suborder is further divides each order based on soil moisture regimes or specific properties. So there are total 68 suborders. Then we have a grade groups. So grade groups, the more detailed classification based on horizon characteristics, climate influences, and soil chemistry. And there are around total subord grade group is around 250, while After grade group, we have a subgroup. So subgroup is again defined with the grade group that distinguish soil with transitional or unique characteristics. And then after we have a family. So family is a classification based on physical and chemical properties like texture, mineral composition, and temperature regimes. And that family we have more than 8,000 family. And finally we have a series that is the most specific category identifying soil at a detailed level based on location and district horizon. And we have more than 19,000 soil series. So this classification basically come under soil taxonomy. So soil taxonomy classifies soil into the six hierarchical levels ranging from broadest to the most specific. And this is the soil textural triangle. So if you know the soil sand, silt, and clay content, then you can directly identify which type of soil it is. So here, how many orders are there in USDA soil classification system? So there are 12 orders. Okay, that order is based on the formation processes and dominant soil properties. Correct answer is option B. Next question, the tillage involves any working compacted after primary tillages. Basically, once we have done the primary tillage and after that we are generally following secondary tillage. So let's identify auxiliary tillage, secondary tillage, zero tillage. So correct answer is option B, secondary tillage, right? Secondary tillage we are generally following after primary tillage operation. So correct answer is option B. And this tillage operation performed to define soil structure, break down large soil clumps, and prepare a fine seedbed for planting. And it includes activities such as harrowing, leveling, subsoiling, sowing, ridging fertilizer, or using rotary tillage. While auxiliary tillage refers to any additional tillage operation carried out between primary and secondary tillage, or secondary tillage to manage weeds, that to incorporate fertilizer or improve soil condition. It usually performed for specific agricultural needs rather than for general soil preparation. And we know that in zero tillage, it is also known as a no-till farming, and it is a conservation tillage practices where soil is left undisturbed from harvest to planting except for minimal disturbance when seeds are sown. Next question. One crop is planted in residue of another with virtually no tillage is called. So we know that that is known as no-till. Okay. And we know that there are various benefits of no tillage operation, like it helps us to improve the water holding capacity, it reduce the soil erosion, and also reduction in CO2 released from the soil. Help us to improve the water quality due to the decreased sediment runoff, right, at the downstream. Also improve the soil health overall, and it help us that require less need of fossil fuel powered machinery. So correct answer is option C. Next question, most soil have a particle density of about, we know that particle density of most of the soil is around 2.65 gram per cc. So correct answer is option A, that is of nearby to 2.65. Particle density is around 2.65 because we know that soil particle density primarily depends on mineral composition of particles. And density, you know that is generally mass by volume, right? So here, in case of particle density, it is mass of solids divided by volume of solids. So the majority of soil minerals are composed of quartz, feldspar, and other silicate minerals, which have density close to 2.65 gram per cc. While organic matter have a lower density around 1.22 1.5 gram per cc, but since it makes up a small portion of most of mineral soil, it does not significantly affect the overall particle density. So heavier minerals like iron oxides and uh, mag, uh, magnite can increase the particle density, but they are present in much smaller quantity in most of the soil. So in general, soil particle densities are mainly influenced by mineral composition. That's why, and most of this mineral is composed of feldspar, quartz, and other silicate materials, and that quartz and silicate dominant materials have particle density of around 2.65 gram per cc. So that's why correct answer is option A. Next question, which what is the effective diameter of micro pores? 2 mm, 5 mm, less than 0.08 mm, and none of the above. So we know that we have total three kind of pores, that is a micro, meso, and macro pores. So micro pores have a size of less than 0.08 mm and that help us to retain water against gravitational pull and making less available for plant uptake. While mesopores that store the plant available water and its size is between 0.03 mm to 0.08 mm, while mesopores that that allows easy of drainage and air movement. So correct answer is option C. The difference between field capacity and hygroscopic coefficient is termed as. So we know that hygroscopic water, that water is adheres to the soil particles, and this hydroscopic water is generally occurring at wilting point, that is around 15 bars, while capillary water, so water that is held in a large pores, that is available for crop use, and gravitational water that drains through soil profile and that is available at field capacity of one third. So the difference between field capacity and hygroscopic coefficient is known as capillary water. So correct answer is option B. Don't confuse with available water and capillary water. So let me quickly describe both. So available water is water between field capacity and permanent melting point, while capillary water is water held in micropores by capillary forces. So available water is readily available to the plants, while capillary water is partially available as some of the water is tightly held to the soil particles. So in this case, capillary water, some are the plant available water, but some are unavailable to plant. And generally, if you can see this available water found in loamy soils, it is maximum available water. Also in sandy and clay soil, where capillary water found mostly in a finer textured soil like clay. Okay. So correct answer here is option B. Next question, what is the soil water potential in bar for 0 centimeter height of unit column of water? So we know that soil water potential is the measure of energy status of soil water, right? So soil water potential give us energy status of soil water. That indicates how tightly water is held in soil and how easily plants can extract it. It means what amount of work needs to be done by plant to extract that water. It determines the movement and availability of water in soil system. And generally we know that 1 bar is nearly equal to 10 meter of water column and it approximately equal to 1000 centimeter of water. So 1 centimeter of water is nearby 0.01 bar, and that's why uh, uh, in bar 0 centimeter of uh, unit column of water is nearly equal to the zero. Correct answer is option C. And let me also define other potential like gravimetric potential, matric potential, osmotic potential, pressure potential. So gravimetric potential, that's basically due to the height of water column above the reference level. So water movement is only occurred by the gravitational force, while metric potential, so it forms adhesive forces between water and soil particles, usually that is negative, and osmotic potential, that is due to the dissolved salt, that is important in saline soil, that are also negative, and pressure potential, that positive in saturated soil like flooded conditions. So all this combinedly form the soil water potential. That ultimately shows the energy status of soil. It means how tightly water is held in the soil. In this case, correct answer is option C. Next question, which potential develops due to the presence of solute in water? So we know that if there is a solute present in the water, that forms osmotic potential. So osmotic potential also called the solute potential, and the key concept in a soil water relationship, and is one of the components of total water potential that we have discussed in last slide also. And osmotic potential is a reduction in water potential due to presence of dissolved solutes in soil water. It is always negative because solutes lower the free energy of water. And how osmotic potential works? So whenever water moves from high potential to lower potential, here high potential means where there is a lower solute concentration, and low potential means where there is a high solute concentration. So water will generally move from high potential to lower potential, and in saline soil, osmotic potential becomes very negative. That makes it harder for plant roots to absorb water, and that soil moisture that is not easily accessible to plant, and that ultimately cause the physiological drought in the soil. Correct answer is option B. Next question. Identify from the following the instrument used in a plant indicator based method of irrigation scheduling. Time domain reflectometry, porous block, tensiometer, and infrared thermometer. So we know that this TDR, porous block, and tensiometer are uh, uh, measuring the soil moisture content, and this soil. So we are providing irrigation based on soil moisture condition. While in case of infrared thermometer, so that measures the temperature of plant canopy, which correlates with the plant's water stress. And it used in a plant indicator based method for irrigation scheduling as plant temperature increases with water stress. Right, as I discussed, that plant infrared thermometer, it measures the temperature of plant canopy, and when plants experience water stress, the stomata close to reduce water losses, which leads to increase in leaf temperature. By monitoring this leaf temperature changes, we can determine when irrigation is needed to alleviate the plant stress. Correct answer is option. Next question. What is the primary difference between volumetric water content and gravimetric water content? So we know that volumetric water content measures the volume of water per unit of total volume of soil, including air and solids. And in contrast, geometric water content measures the weight of water per unit weight of dry soil. Right. And this definition highlights the fundamental difference in how each method quantifies soil moisture. So generally in field, we are farmers generally using volumetric water content, right? Because it provides total water content in real condition. Instead of we are not considering air and other solid particles. So here correct answer is water content is measure of water volume per unit of total volume. So it is correct, right? Option B. 300 gram of soil sample contains 75 gram of water when 60% of pores are filled with water. Calculate the porosity of soil sample. So we know that porosity of soil sample is equal to total pore space divided total soil volume. So here total pore space, let's first calculate it. So we know that determined over dry weight of the soil. So we have a total 300 gram of soil sample, and that contains 75 gram of water. So dry sample mass is 2 to 5 gram of solids. And let's calculate the volume of solid. So we know that particle density of any soil, mineral soil, is a 2.65 gram per cc. That is a standard, and by considering this, we can calculate the volume of solids. So that is around 84.9 centimeter cube. And then, as the porous is given, like 60% of pore space are filled with water. So 60% of this total uh, soil solids. So so that is around 125 centimeter cube. And considering this, like 84.9 plus 125 centimeter cube, we have a total soil volume of 209 centimeter cube, and then we can calculate porosity easily by putting it here. So porosity is coming around 60%. Next question, which soil has a more leaching of pesticides? Clay soil, silty soil, sandy soil, and loamy soil. So we know that among all these, sandy soil have a higher leaching capacity of any organic or inorganic contaminants, because we know that there is a huge particle size difference between it. Sandy soil have particle size difference of particle size is in between 0.02 or it is 2 to 0.02 mm, right? Then we have, sorry, 2 to 0.2 mm, then 0.05 to 0.2 mm, and 0.02 to 0.002 mm, right? So this is the particle size distribution, and this is directly impacting or each soil, what soil properties, whether it is physical, chemical, or biological. In case of leaching, the sandy soil have a more porous space available, larger porous space available. So that's why it is not able to hold much water, and that ultimately leads to the leaching. Saturated flow occurs downward, horizontal, and upward, and all of the above. So we know that a saturated flow, so generally there is a, if you go beneath the earth's surface, there is a zones like unsaturated zones, saturated zone, there is in between transition zone, and there is a uh, bedrock aquifer. Okay. So whenever water will move from upward to downward, and you know that it is not like that everywhere the water level, the saturated zone is above only below the surface. For example, in northern Indian condition, we have higher groundwater level. It means it have a lower thickness of unsaturated zone, while if in other parts of the Indian regions like South India or other like wherever there is a hard rock aquifer, in that case we have a greater depth of unsaturated zone. So basically here the key takeaway that you need to consider is the water movement is starting towards saturated zone as a downward flow. Then the saturated zone, what are the water available in this? The saturated water is also moving horizontally. In addition to that, water is also moving towards the plant roots, or this action is also known as capillary action, and this is towards upward direction. So correct answer is option D, right? All of the above. Darcy's law is applicable to which type of flow in porous media? So we know that Darcy's law is generally applicable to laminar flow, right? Correct answer is option B, because laminar flow is a smooth and it is generally occurring in soil type of condition, because water movement within soil is a, it have a very low velocity, and orderly movement of fluid in a parallel layers with a minimal mixing between them, and each practice of fluid follows a well-defined pattern, velocity at any point remains constant over the time. So it is typically occur at low velocity and low Reynolds number, that is less than 2000. Next question, infiltration is the process of water entering the soil surface from rainfall or irrigation. It is correct, right? The first entry of water into the soil is known as infiltration. So this is correct answer, and this is the entire hydrological cycle, right? That we have also discussed throughout the uh, big throughout all required lectures. So I'm not going into detail. Next question: which of the following factors primarily determine oxygen availability in soil? So oxygen availability is related to the air movement. So we know that soil pores are the major factor. So particularly macropores, that is size of greater than 0.08 mm, that governs the oxygen availability in the soil. So correct answer is option A. Which process involves oxygen acting as an electron acceptor during the oxidation of carbon by living organisms? So we know that in this is the in case of redox potential. So correct answer is option because it refers to the tendency of subsurface acquire electrons and thereby we reduce. In soil living organism, this release electron during oxidation of carbon energy and oxygen act as an electron acceptor making it oxidize in nature. Clay in water is an example of dash type of colloid. We know that clay in water is solid in liquid type of colloid and liquid in so correct answer is option A. While in case of liquid in gas colloid, so its example are mist, clouds, and aerosol sprays. While solid in solid colloids are like colored glass, alloys, and gemstone rubbish. So let's move towards next question. Which of the following clays has no swelling capacity? So we know that yeah, kaolinite, molinite, A and B, and none of the above. So kaolinite that have a no swelling capacity. Why? Because so first let's understand. So kaolinite and molinite are two different types of clay minerals and differs in structure, properties, and behavior in soils. And kaolinite is one gem, one type of clay minerals. Okay, meaning it consists of one silica tetrahedral sheet. So you can see here kaolinite structure, right? So it forms of one tetrahedral sheet and one alumina octahedral sheet, and it has a low shrink swell capacity due to strong hydrogen bond between layers, making stable, non-expensive, and relatively low in cation exchange capacity. So you can see this hydrogen bond between tetrahedral sheet and one aluminium octahedral sheet. So this sheet get attached with the very strong hydrogen bond, and that makes it stable, non-expensive, and relatively low cation exchange capacity soil. So kaolinite is commonly found in highly weathered tropical soils and used in industries like ceramics and paper and coatings. Okay. While mant molinite, that is a 2 gem, one type of clay mineral soil. So in this case, this consisting of two silica tetrahedral sheet sandwiching one aluminium octahedral sheet, which allows significant swing swell capacity. So in general, it is two silica tetrahedral sheet that uh, sandwiching one aluminium octahedral sheet. And due to that, it have a higher cation exchange capacities. It helps us to make better soil fertility and nutrient retention. That's why correct answer is here for no swelling capacity is kaolinite. The kaolinite is one type of clay. Yeah, it is nutrient poor. It is, yeah, it is nutrient poor because of strong hydrogen bond between tetrahedral and octahedral sheet, and it also have a less shrink cell capacity or no shrink cell capacity. So correct answer is option D. Which of the following colloid has highest cation exchange capacity? Smectite, vermiculite, humus, or chloride? So we know that humus has the highest cation exchange capacity among the given option due to its highest surface area and negative charges and organic nature, allow it to hold and exchange large number of cation essential for plant. While smectite, that is 2 gem 1 type of clay with high shrink cell capacity and moderate to high cation exchange capacity. Vermiculite is another 2 gem 1 type of clay, has a higher cation exchange capacity than smectite due to more interlayer cation retention. And chlorite is 2 gem 1 gem 1 clay mineral, has a low cation exchange capacity due to its additional hydroxide interlayer. So correct answer is vermiculite, right? Because it asks about colloids. If it is general question, then answer will come humus, but they ask the colloids. So which of the following colloids is the highest cation exchange? So vermiculite have a highest cation exchange capacity. Cation exchange capacity is expressed as number of moles of positive charge absorbed per unit mass. So yeah, this is the correct, right? Because it expressed as moles of positive charge adsorbed per unit mass of soil, and is typically expressed in centimoles of charge per kilogram of soil or milliequivalent per 100 gram of soil. Percentage based saturation is calculated using which formula? So we know that percentage based saturation, that is generally calculated by exchangeable base cations divided by cation exchange capacity into 100. So exchangeable base cations divided by cation exchange capacity into 100. That is the correct answer. Next question. The electrostatic force depends on charge, positive position of charge, the valence of electrochangeable cations, and all of the above. So try to think about this question, and let's take one small break here. Then we'll try to cover rest of the question that left out. So let's pause here, and I will be here by 5 to 10 minutes. Come back, guys. So let's continue our session. So next question is electrostatic force depends on position of charge, and valence of cation exchangeable cations. So in soils, we know that electrostatic force refers to the repulsive force between soil particles caused by their electrical charges, essentially acting as a barrier to particle aggregation and significantly impacting soil structure, water movement, and stability of soil aggregates. So electrostatic force is repulsive force between soil particles due to their electrical charges, and that it depends on multiple factors. So firstly, charge, that is crucial as force is increasing with magnitude of charge. So greater the charge is result in stronger attraction or repulsion. Secondly, position of charge is significant because of distribution and relative location of charges influencing electrostatic interactions. For example, closer charges experience stronger forces. And thirdly, valence of exchangeable cations. So that affects electrostatic forces in soil because higher valency cations like aluminium plus 3 and calcium plus 2. So all of the above are correct, that ultimately impacting electrostatic force. You can see this figure, right? So this is soil particles, and the soil particles have three kinds of layers. So one is a fixed layer, then we have diffuse layer and weakly bound water. So fixed layer have a strongly bound water, while diffuse layer have a weakly bound, that also known as free water. Correct answer is option D. Potential follows a linear distribution in Helmholtz double layer model. So this is the correct option, right? So this is the Helmholtz layer. You can see this. This potential follows linear distribution between these two layers. While in case of diffuse layer, there is a two layers, that is term layer and diffuse layer. So distribution is not linear in nature. It is linear initially, while as it moves toward diffuse layer, it is decreasing exponentially. Correct answer is option A. Which adsorption isotherm is characterized by solute having high affinity for solids? So S type, L type, C type, or H type. So you can see here. So basically, isotherm is representing sorption of the particular contaminant in the soil and its equilibrium concentration in soil solution. So you can see this various behaviors. So first one is the L type. So L type is indicate strong affinity between solute and solid. So right, let's continue. So L type is basically indicates strong affinity between solute and solids, leading to high adsorption at low solute concentration, and that too as adsorption site becomes saturated. C type reflects linear relationship where adsorption is directly proportional to solute concentration. While in case of ash type, so that represent the cooperative adsorption, where initial absorption increase, right? You can see here initially absorption solute affinity for further absorption and often seen in organic compounds. While H type of adsorption isotherm, so
This signifies extremely high solute affinities for solids. You can see it is more towards uh, sorbed amount, right? Even at low concentration, so there is a high sorption on the solids and often leading to irreversible adsorption with steep initial uptake. So correct answer is option. Uh, at a very high concentration, X by M becomes constant according to the Langmuir adsorption equation. So, Langmuir adsorption equation describes monolayer adsorption where molecules occupy discrete adsorption sites on solid surface. Okay. It means Langmuir is related to the monolayer adsorption description and it assumes that once site is occupied, no further adsorption can occur at that spot, leading to saturation point. At a very high concentration, the adsorption, that is X by M, reaches maximum limit because all available adsorption sites are occupied, making further adsorption impossible. And this explains X by M becomes constant at high concentration. So this is the correct answer here. A is next. Which of the following isotherm model proposed for sorption processes? So we know that Freundlich equation adsorption isotherm is an empirical model that describes adsorption of solutes onto soil surface assuming heterogeneous surface energy and multilayer adsorption. Okay. While Langmuir isotherm that is assumes monolayer adsorption onto homogeneous surface with finite adsorption sites. It describes sorption that reaches saturation at maximum adsorption capacity. And friendly isotherm is commonly used because describing sorption in environmental and soil chemistry. So correct answer is option A. While we have also Bate equation and Gibbs equation that also we are using in certain conditions. So these are the details of each isotherm, that is S type, L type, C type, and H type, and also various isotherm, that is common one is friendly isotherm because it is a empirical model that describes non-uniform adsorption, heterogeneous surface, while Langmuir isotherm is providing monolayer adsorption on homogeneous surface. And it friendly is useful for nutrient and polluter adsorption, while Langmuir is useful in predicting maximum adsorption capacity of soil. Well, third one is a Temkin isotherm, so it accounts for adsorbent, adsorbent and adsorbent interaction and adsorption energy variation, used for studying chemisorption process in soil. Okay. Next question: the greater the zeta potential, so it means the more stable suspension, more particles tend to repel each other, both A and B, and none of the above. We know that if the zeta potential is greater, it means there are more stable suspension and the particles tend to repel each other. While zeta potential, it means it measures the electrical charge of a surface of particles in suspension. And higher zeta potential creates stronger repulsive forces between particles, preventing them from aggregating and thus increasing the stability and in the suspension, and particles tends to repel each other. So when zeta potential is high, either positive or negative, so electric static repulsion between similar charged particles increases and that collision and coagulation. So correct answer is option C. The acidity caused by H plus and aluminium 3 plus ions in the exchangeable sites of soil mineral contributes to active acidity, residual active acidity, exchangeable acidity, and potential acidity. So we know that whenever there is a presence of H plus and aluminium 3 plus ion, right? That causes the exchangeable acidity because that absorb onto the soil colloids and can be displaced into the soil solution by cation exchange. Is important factor in soil buffering and influencing soil amendments like slime. Correct answer is option C. Where are the characteristics of what are the characteristics of saline soil? Right. So we know that there are three types of soil, saline sodic soil, and saline sodic soil. So, saline soil have a greater that have a greater than 4 decimeters per meter electrical conductivity, but its exchangeable sodium percentage is less than 50, right? And its pH is nearly around 8.5. So correct answer is option B. Next question: what is the relationship between redox potential and PE? So we know that Uh, PE is used instead of redox potential sometimes to characterize submerged soil. So PE concept that we are generally using for submerged soil, and this concept is given as PE is equal to minus log E is equal to EH by 0.0591. So PE is negative algorithm for electron activity. PE is large and positive in strongly oxidized system, and it low and negative in strongly reducing system. Correct answer is option C. Right. P is equal to EH by 0.0591. Next question: the sodium adsorption ratio (SAR) gives information on comparative concentration of sodium, calcium, and magnesium in soil solution. So this is a true sentence, right? Because sodium adsorption ratio is a key indicator used in soil science to determine relative proportion of sand, sodium to calcium and magnesium in soil solution, and it provides crucial information about potential for soil dispersion and structural degradation due to excessive sodium, right? So higher the sodium adsorption ratio, it indicates greater sodium dominance, which can lead to poor soil permeability and reduced water infiltration because of soil uh, coagulation. Okay, you can see here, if there is a higher electrical conductivity, it means there is a dispersed soil, while lower electrical conductivity that leads to a populated soil. Which of the following factors contribute to the high soil pH? So we know that soil pH, there is a generally it is due to the carbonate and bicarbonate compounds, and often form a limestone rich parent materials or irrigating water compound that leads to alkaline soil condition. So higher pH, it means there is an alkaline condition. It means pH is greater than 8.5. And the correct answer for this is presence of alkalinity sources such as carbonate and bicarbonate compounds that leads to the soil high pH. Right. Correct answer is option. Which of the following is a primary method for reclaiming sodic and saline sodic soils? So we know that in case of sodic and saline sodic soil, what we are doing, we are replacing sodium with calcium plus 2 ion using gypsum. So in sodic and saline sodic soil, we are adding gypsum, okay, to replacing sodium with calcium. So replacing sodium ions with calcium using gypsum is the correct answer, right? Next question. So yeah, this is the fundamental of plant essential nutrients. So we know that this we have already discussed that Essential plant elements are divided in two parts. The one is the framework elements and second is mineral elements. So framework elements, that is CH and O, that is carbon, hydrogen and oxygen, while mineral elements, that is again divided into two parts, that is macronutrient and micronutrient. And micronutrients again divided in two parts or classified in two parts, that is primary nutrients and secondary nutrients. So primary nutrients, we know that primary macronutrients is NPK, while secondary macronutrient is calcium, magnesium and sulfur. And all these are the fundamental, right, about CHO and why it is important for any basic crop. Which of the following is a framework element for plants? So framework element and second is mineral element. So framework element is here, N is not, Mg is also not there, C is carbon is framework element. So correct answer is options. Next question, which of the following are considered a beneficial plant nutrient? So beneficial plant nutrient is, we know that cobalt and silicon both are beneficial plant nutrient, while calcium is, it is essential macronutrient, right? So correct answer is option A. Cobalt and silicon both are beneficial nutrients. Major forms of inorganic nitrogen. So inorganic nitrogen major form is generally it is ammonia, ammonium and nitrate. So you know that nitrogen cycle that we have discussed in detail in the in this macronutrient lecture. And the major inorganic form is ammonium and nitrate. Correct answer is option C. Next question, which of the following statements are correct? More than the clay, more the clay contain more phosphorus fixation, less release of phosphorus for plant. So yeah, this is the correct answer because we know that if there is a higher clay content that have a higher cation exchange capacity, means higher soil silicates, and that generally allows more phosphorus fixation, and that uh, release less phosphorus for plants. So correct answer is option. Arbor process is related to the, so this process is generally related to the nitrogenous fertilizer, right? So correct answer is option A. Not going into the detail of all this as we have already covered, right? You can stop me if you have any query between. Which of the following factors can lead to toxicity of micronutrients in plant? So we know that generally the higher the soil pH, okay, that have alkaline condition, and that the availability of many micronutrients like Fe, manganese, and iron, zinc, that decreases, making them less toxic. But in case of lower pH condition, that is acidic condition, that causes increasing solubility of toxic elements like aluminum and manganese. That leads to the higher toxicity. So correct answer is option B. Which of the nitrogen is most mobile in soil and prone to leaching? So ammonium, nitrate, urea, and organic nitrogen. So this inorganic form of nitrogen, that is nitrate and ammonia, among these two, the major most mobile form of nitrogen is nitrate. Okay, that is NO, that are generally also discovered in groundwater by various global study of a intensive agricultural region due to excessive application of nitrogen fertilizers. Correct answer is option. Next question, why is the carbon nitrogen ratio is important? We know that CN ratio is very important due to it influencing the microbial activity in the soil, right? Fungal dominance or some important microbial activity. The higher the CN ratio, that slows down the nitrogen availability of the plants. So that is also correct. And a low CN ratio leads to rapid nitrogen mineralization. That is also correct, right? So whenever organic materials when low CN ratio decomposes, it accesses the nitrogen released into the soil ammonium or nitrate, making it readily available to plant. So all of the above are correct in related relation to the carbon nitrogen ratio. The ideal number of soil sample to be collected for testing from 1 hectare area is, we know that this is 20. Correct answer is option B. What is the depth of sampling for grasses and grasslands? So we know that the depth of sampling we are generally considering based on the root zone depth of the particular crop. So in case of grasses and grasslands, the depth of sampling is around uh, 5 uh, 5 centimeter or 15 centimeter. Okay, but in general we have most of the grass that is in range of 5 centimeter depth, its root zone. So we are considering 5 centimeter as an ideal depth for sampling of grasses and grasslands. Correct answer is option D. Which extractant is used to extract available nitrogen for soil testing? So in case of available nitrogen extraction, in case of soil testing, we are using KMNO4, that is potassium permanganate, and generally we are using it in the alkaline form, so it is known as alkaline potassium permanganate. So correct answer is A. While DTPA that we are using is a chelating agent that used to extract micronutrients like zinc, iron, copper, and manganese. While ammonium acetates that extract commonly used for determining exchangeable cations such as potassium, calcium, and magnesium. Which element is not measured using flame photometer? So this is flame photometer, and this working principle we have already covered in our summary session. So this is generally we are using to measure major cations. So major cations like calcium, magnesium, sodium, that is Na, and potassium. So correct answer is potassium, calcium, lithium, and phosphorus. So phosphorus we cannot measure using flame photometer. Correct answer is option D. Which organisms are known as the intensity of Earth? So we know that earthworm is known as intensity of Earth. An environment under the influence of roots is known as, so the environment that are influence of the root, that is known as rhizosphere. We know that, right? So correct answer is option D. While biosphere is a global ecological system that influence all living organisms and their interaction with environment. While lithosphere refers to the outermost layer of the earth, including the crust and upper mantle. And hydrosphere, that is related to the hydrology, and it defines water bodies on earth such as ocean, river, lakes, and groundwater. And rhizosphere is related to the environment under influence of roots. Correct answer is option D. Most important algae from an agriculture point of view are, so we know that among the blue, green algae, yellow algae, and golden brown algae, blue green algae, that is also known as phyta, that are very important for agricultural point of view, because cyanophyta also known as blue green algae and play significant role in agriculture by fixing atmospheric nitrogen that improves soil fertility and enhancing crop productivity. They are commonly used in paddy fields to boost nitrogen levels naturally. Next, which form of phosphorus is primarily taken up by plants? We know that this dihydrogen phosphate is the commonly inorganic form that generally taken by plants. So correct answer is option A. Which of the following methods is used to extract available potassium from the soil? So to extract available potassium, we are using sodium bicarbonate. So we are not using sodium bicarbonate. Ammonium acetate? Yeah. So correct answer is ammonium acetate that we are using to extract potassium and uh, that generally replacing exchangeable potassium from clay particles due to similar ionic size. Correct answer is option B. Which of the following is chemical soil degradation process? So we know that there is a physical degradation and chemical degradation. So chemical degradation among this is depletion of organic matter, soil compaction. No, this is also correct. So erosion by wind, that is physical. So alkalization is the correct answer. And alkalization is a process of soil becoming alkaline, can indirectly contribute to the chemical erosion by increasing the solubility of certain minerals and potentially making soil more susceptible to erosion. And alkaline is characterized by rise in soil pH, often due to accumulation of sodium carbonate and sodium bicarbonate that increase solubility and disperse the soil structure. And that makes them more prone to erosion. Correct answer is option C. Usle cannot predict the soil loss for which type of soil erosion. So we know that Usle is generally not predicting erosion for gully erosion. So correct answer is option C because it accounts sheet and reel erosion, right? So there is a formation of erosion process. First erosion is a splash erosion. After splash erosion, we have a sheet erosion, and then sheet. If that sheet erosion is not get prevented, then there is a reel erosion in the field, and after reel erosion, there is a gully erosion. So there is a final stage of erosion, and the gully erosion is form a channel-like structures. Yeah, so this is the basics about erosion that I'm not going to cover in detail as I already covered. Next question, wind erosion can be controlled by using which of the following measures? Increasing soil moisture, yeah, so obviously by increasing soil moisture that bound the soil together and that prevent the effect of higher wind. Increasing soil cover, yeah, obviously you can see here if we are covering soil with the some grasses, some forest trees that help us to again binding the soil and that ultimately uh, reducing the impact of wind erosion and shelter band and wind breaks that are the specifically types of wind erosion control structures. So all of the above are the correct answer for this. What is the effect of conservation tillage on soil properties? So we know that conservation tillage generally help us to increase bulk density, it decrease the cation exchange. So no, it is increasing cation exchange capacity. It is unfortunately correct. It increases organic matter. Yeah, this is the correct. And as a result, there is improvement in cation exchange capacity, and that help us to improve nutrient availability. Correct answer is option C. Next question. Surfactants role in soil is act as, so we know that surfactants that acts as a detergent, wetting agent and emulsifier. So all of the above are correct for this. So detergent, so surfactant can function as detergent by breaking down, removing hydrophobic contaminants like oils and greases into from the soil. It also acts as a weighting agent, so that reduce the surface tension, allowing water to spread more easily and infiltrate to the soil, and also act as a emulsifying for non-polar contaminants. Next question. Remediation of soil organic pollution can be achieved by bioremediation, physical and chemical methods, and phytoremediations. Yeah, so all these techniques are generally we are using for remediation of soil organic pollutants. Correct answer is option D. So these are the fundamental. So aging is generally physical, chemical, and biological changes that contaminants undergo after being introduced into the soil, and these changes reduce their mobility and bioavailability. Bioavailability we are generally considering instead of total concentration while designing remediation techniques. So next question, diffuse reflectance spectroscopy can be used for which of the following parameters? So we know that diffuse reflectance spectroscopy are we are generally using for all the major kind of soil physical and chemical parameters like organic carbon, moisture, and available nitrogen. So correct answer is option. So these are the basics about diffuse reflectance spectroscopy and XRF, that is portable X-ray fluorescence. I'm not going into detail as we have already covered in week number 11 only. So yeah, I think all these are already we have covered yesterday. So you can refer my week number 12 lectures. So remaining question I have already discussed. So I'm not going into the more details of this. Instead of I would like to provide you some times to interact with, and if you have any query, you can ask. Right. So all these are the basics of the machine learning and some geostatistical method that we have covered in week number 12. Yeah, so yes, this is the end of this session. So this is, I think, uh, helpful for you, and I hope you enjoyed this course and this discussion or whatever session I have covered till now. That will be helpful for your exam also. So thank you so much for joining and being with me in this entire journey of this NPTEL course on soil science and technology. So again, I would like to request you to watch out all the content or major concept that I've covered to this YouTube channel, and also you can access all the lecture materials from this Google Drive course. And I would like to again request you to provide your valuable feedback for this course, basically for what I have covered and what I need to include more in this course. And if there is a chance of improving content delivery, you can also mention that. So your feedback will help me to improve this content as well as delivery nature. So with this, I am ending here, and again thanking you for joining with me. Thank you.